Last lesson, what we looked at was the Q1, Q3, max and min to calculate the range and the interquartile range. We'll also use those values that we can obtain, called the 5-figure summary. So that is the min, the Q1, the Q2 or the median, the Q3 and the maximum, to generate this 5-figure summary and subsequently a box plot. Now this part here, as the arrow suggests, this is what we call the box. Now a lot of people refer to this part here as the whisker, okay? So that's why it's also called the box and whisker plot. What we do with a box and whisker plot is if there is an outlier, we indicate that with a cross. And then what we do is we represent each of the groups, the 25% groups, with one segment in the box plot. It's a really quick way to actually get an idea of how the data is spread out and where the values, the different groups, where they fall between. It also allows really good comparisons. So what we do is we look at these things called parallel box plots, and I'll present one to you right now. So up on the screen now will be an example of what schools get when they obtain or get when students sit a NAPLAN. Okay, so this is fictitious data. So first of all, just make sure that you know that this is not Sacre-Cœur data. This is an example of what schools get from the NAPLAN website. Now, what remember you do is you do 5 different testing scenarios: reading, writing, spelling, grammar and punctuation, and numeracy. Okay, and you can see here what we do is we then get this data on our school, whatever the school is. So this is, so let's call it school X, we don't know. And what we can do is compare school X's results with this one here. That's the state reading results. Okay, and you can quickly see here the median for the school is well below the median of the state. Okay, and the state here, whatever state it is, it might be Queensland or whatever, their median falls above the national level. So this would be like where the state's going, yeah, we're doing pretty well here. Okay, the nation will be going, ooh, we need to catch up to Queensland. And the school here might certainly be going, what is going on with our reading here, and how can we actually boost it up further? And so you can see here, you get this great comparison of how you stack up against the state in different things. Now remember, box plots here are independent of the number of results that they get. So this school here might have had, say, 300 Year 9 students that sat the NAPLAN. In the state, wouldn't have a clue how many thousands of kids sit the NAPLAN, nor would I have a clue about in the nations. But notice how we still get this great comparison of the data. And you can quickly see here, look at this, like the school just slays spelling. So what is going on with spelling, and why are they going so well in spelling and not reading? And again, what the school can do is go, well, obviously we're doing really well in spelling. Maybe we'll reduce the time we spend on spelling by a bit and focus a little bit more on the reading component and see if we can get that up. So you can see here also that schools can make really good decisions based on the data. Okay. Now remember, these boxes or these different segments comprise of 25% of the data. So you can also do pretty good comparisons. So with spelling, you can see that the top 50% of the particular school in question is going significantly better than the top 50% here and the top 50% here. Okay, so again, what we can do is compare groups as well. All right, so back to the notes here. So let's get into it, girls, by considering this data set, and what we're going to do is generate the 5-figure summary. So I'm going to get my calculator to help me this time with this process. So we're going to go 5, 9, 4, 3, 5, 6, 6. Make sure you're playing along at home. 7, 12, 2, 3, 5. I always just quickly double check the amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Lines up with 13, which means I've probably done that correctly. Now to get the 5-figure summary, we go to the one variable statistics. Point it to the list that we want the one variable statistics for, and if it's not in a frequency table, we'll leave that default value to 1. All right, so here are our stats, and the ones we're interested in here start here. So our min, that's pretty easy to see off the data itself, is 2. The Q1 is equal to 3.5. The Q2 or the median is equal to 5. The Q3, it looks to be 6.5. And yeah, it was. And the max is 12. So we've got 1, 2, 3, 4, 5, the 5-number summary. Whoops, I've just put that into the wrong section there. Can you please make sure that your 5-figure summary goes here? I'm going to swap these questions. My bad, girls, my bad. All right, so there's the 5-figure summary created. Now what we're going to do is determine the upper and the lower fence to see if any of these pieces of data are outliers. Now let's just have a quick squiz at the data and see if we can spot anything that looks unusual to begin with. So the lowest value is 2. That doesn't seem that unusual because there's like a 3 and then another 3. Okay, so 2, I doubt very much whether that will be an outlier. Let's have a look at the other end. So the highest number is 12. The next highest number is 9. So 12 could be, like, that'd be like, oh, we got 9, and then we got a 7, and then we got 2 6s, and then we got a 12. So I'm not sure whether 12 is an outlier, but that's the one I'm really interested in. But we want to do both checks. So the question says do both fence checks and see whether there's any outliers. So recall that the lower fence is equal to the Q1 take 1.5 times the IQR. You'll get a formula sheet for that, so don't spend any time trying to memorize that. The upper is equal to Q3 plus 1.5 times the IQR. All right, let's jump over to the calc and get it to help us out with these ones here. So we're going to go to the main section, and our Q1 in this case is 3.5. Take away 1.5 times the interquartile range, which I can see Q3 take Q1 is equal to 3. So the lower fence is -1. So anything below -1 is going to be an outlier. So clearly all those low numbers there are all good. They're not outliers. All right, now let's make a quick change to this. It's plus, and we type in the Q3, which is 6.5, and the upper fence is 11. All right, so 12 is certainly an outlier, and we're going to justify that by writing 12 is greater than 11, therefore outlier. Now note that it doesn't have to be just one outlier value. There can be 2, there can be 3, there can be 100 outliers if the data set is really, really big, okay? So 12 is an outlier in this case, but there could be more. All right, so what we're going to do now is pop this data into a box plot, and here is the process that I use. So what I do is I make 5 notches on the Cartesian plane that I'm going to put it on. So the minimum is 2. So I choose basically a section to present it. You could do it really low, but I'm going to do it here. All right. So I'm going to put a notch about that big at 2. You can make the notch bigger if you want. All right. Now I'm going to do the Q1, which is 3.5. So here's 3. There's 3.5 right there. Now I'm going to do the median, which is 5. So I'm just putting notches at each of the 5 number summaries. The Q3 is 6.5. Right there. The max is 12, but we've got an outlier. So the maximum is an outlier. So what I'm going to do is put an asterisk or a star or a cross at the outlier point. And here's the key thing. So please, please think carefully about this. So what we do to put the next value in, we don't put the upper fence value as the point for the notch, okay? The upper fence is just a theoretical value. It's like you and I as statisticians are going to go, anything outside of the range of -1 to 11, between you and me, let's call that an outlier. They are the kind of rules that we've established between us here. So that actually isn't a value in the data set. So to get this maximum value here, what we're going to do is find the next maximum or next highest value beyond 12, and that's 9. So 9 is where the notch is going to go, not 11, not the upper fence. All right, then when I've got my 5 notches in, what I do is I form the box component by drawing a horizontal line connecting the middle 3, and then a whisker connecting the outside 2. Okay, so there's my box and whisker plot. Now it's usually a good form to rule that up, all right? Mine's a little bit dodgy looking. It's also a good form to label the horizontal axes with any context. There's no context here, so we can't really label the axes in terms of what it actually displays. But that's everything that we've got. We don't need to label these things. Sometimes I see students labeling min, Q1, or even putting the values in, but there's no need to actually do that sort of stuff. Right, so there's our very first box plot. All right, now let's go on to have a look at parallel box plots. And what parallel box plots allow us to do, like that NatPlan data, is to do a comparison. Because in business, what we might be doing is comparing departments. Who's the better performing better performing section of the business? How do we know who's performing better? What we do is we compare them. All right, so what we do with these is we have, in this case here, parallel box plots summarising average fuel consumption litres per 100 kilometres for a group of Aussie cars and Euro cars. Okay, here's the Euro cars here. Notice that these boxes need to be labelled. Okay, so Australian cars are here, European cars here. Answer the following question using data from the box plot to support your answer. What does each box plot represent? Okay, what it represents is 25% of the cars measured in terms of fuel consumption. All right, so this here represents 25 or the lowest 25% of cars in terms of fuel consumption. They're like your Toyota Priuses or stuff like that. This here represents like the upper 25% of fuel consumption. These are the gas guzzlers, your Holden Commodores, VL Calais Series 2 turbos, things like that. Okay, I'm just like reeling off names of cars. I know nothing about cars, FYI. Now, European cars here, you can see again, same thing, 25, their top 25%, including this one outlier or possibly even two outliers. So there's 15 occurring twice there as a possibility. And what we're noting here is that, yeah, we've got one or more outliers here. Like these European cars seem to be on average more fuel efficient, except for these bad boys here that really chew up the petrol. All right, what do the box plots say about how the fuel consumption compares between Australian-made and European-made cars? Well, this certainly is not enough space to write our answer, okay, because we've got a lot to say in comparison. And what I'm going to do is give you a basic script to answer this one so that in Year 11 and Year 12 further mathematics, you already know how to answer these questions, but these are classic 6-mark questions in SACS. All right, so what we've got to comment on when we compare is three things: the center of the data, the shape of the data, and the spread. Okay, and when we comment on these things, it's important to provide evidence and context. So these are the key things that we need to provide when commenting on each of these things. All right, because I've got a lot to say here and I've got fairly untidy handwriting, I'm going to swing in a Microsoft Word document and actually type my answer. I'm going to have the box plots there so that I can see it. So the first thing I'm going to focus on is the let's go center. Okay, so that's the first thing I'm going to comment on is the center. Okay, so I'm going to say this: on average, Australian cars are less efficient. According to the median, Australian cars average, what is it, 9 litres per 100 km compared to European cars. So notice the context I'm using here. I'm mentioning the case study. European cars which use 8 litres per 100 km according to the median. So establish that you're using the same measure to compare the center, okay? So again, if you can see what I've done here, I've used context to talk about the center, and the way I'm going to talk about the center of the data is by discussing the median. Because they're in box plots, I actually can't calculate the mean because there's no actual data to state the mean. And also with an outlier, I wouldn't be using the mean as a measure of center anyway. Right, shape. All right, so what we can see here is that the Australian data is what I'd consider in terms of a box plot, roughly symmetrical, okay? So I'm going to say here the shape of the distribution of Australian Australian cars is approximately symmetrical when compared to the European car distribution, which is, and let's just check it out. So what happens with this box plot here is you notice that these values here from 3 to 8 versus 8 to up to 15 here, they've got the values up in this top end or top 50% are much more spread out. And the equivalent in a histogram would look something like this. It'd be like lots of stuff happening at the bottom end and then spread out at the top, which would produce this tail at the top, pos skew. So the European car distribution is positively skewed. All right, so what we comment on now is what we call a spread or the variability of the data. How much variation is there? And to do that, girls, what we're going to do is use the interquartile range. We can't use the range because of these, this or these possible outliers here. So what we're going to do is shrink in here and use this interquartile range for the European cars, which is 10 take 7. That one is 3. And this one here is 11 take 7. That one is 4. Okay. So what we're going to say here is where's Microsoft Word? We're going to say that the European cars are less variable. We're going to say the European 3 according to the IQR when compared to the Australian cars, 4 according to the IQR in terms of their fuel efficiency. All right, so there are the 3 things that we need to comment on. And again, you notice that each time I've provided evidence and each time I've used context. So 2 marks for that, 2 marks for that, 2 marks for that. You guys who go into general maths and further maths, guaranteed SAT question on those, on that stuff there. So make sure you get that down in your notes. This section here, if I do ask a question in an exam on this, will be absolutely the section of the exam where you have your notes. So you need this script in your notes. Okay, so let's continue looking through these questions. So that question there, again, make sure you write down what you put in or what I wrote down on that Word document. Okay, what do you think the cross represents on the European cars box plot? It's an outlier or it could be 2 outliers. So without actually checking the data, this 15 might have come up twice, 3 times, 4 times, and it's been declared as an outlier. So be careful about seeing 1 cross and thinking it might be 1 outlier. It could be 2. All right, is the upper fence of the European cars the next highest value after the outlier? So let's just check that question again. Is the upper fence? No, it's not. Okay, this value here, 12, represents, so we're going to answer this by saying 12 is the next highest figure in the data. And what I'm going to do is prove it to you by calculating the upper fence. The upper fence is equal to the Q3, which is 10, plus 1.5 times the IQR. 10 plus, now the IQR was 3, so 1.5 times 3. And that's going to be 10 plus, what's that? 4.5. That's going to be 14.5. So the upper fence is 14.5, hence why this number here, 15, is an outlier. But notice that the next value here is not the upper fence. We don't put a line at the upper fence. The value is 12, which must have been the next highest fuel consumption measured. How many cars have been tested for fuel consumption in Australia and Europe? Okay, the easy answer to this is no idea. No idea. It could have been thousands of cars. It could have been 10 cars. We don't know because where's the data? All I've got is the end product of the data, which is the box and whisker plots here. So the answer to this one here is don't know. Okay, we don't know because box plots can't show us all the data points like a stem and leaf plot did. Like if we put it in a stem and leaf plot, we'd have fuel consumption like 0, and then we'd have one that used say like 7 litres, 8 litres, 9 litres, 9 litres. Then 1, 10 litres, 10 litres, etc. And we'd know the individual data. With box plots, we simply can't tell. And that's again the case with this NAPLAN data here. Who knows how many students in the nation were actually sitting the NAPLAN? We just don't have a clue. Who knows how many were in the state? Don't know how big that school is. Okay, we can't tell how much is in the data, but what we can do is compare different groups. Okay, could this data be placed in a stem and leaf plot? Explain when it might be feasible. So the answer is, I'm not sure. And it depends on the original data. So if there were 10,000 cars assessed for fuel consumption, then I would be saying, no way am I going to make a stem and leaf plot. If there was 15 cars, then that's okay. And so I'm not sure, again, what the cutoff is or what the acceptable one is, but I'm going to say less than 30 is okay for stem and leaf. Okay, that's like Mr. Miller's sort of guidelines. I'm not 100% sure that that is true or not, and statistics is a little bit loose, but I'm going to say beyond 30, and it's starting to get a little bit silly for a stem and leaf plot. Do the number of cars for, this is the beauty of box plots, girls. Do the number of cars tested for fuel consumption in Australia and Europe have to be the same? The answer is no. For a good comparison, look at this again, we get this great comparison from NAPLAN when the number of students here is completely different. Because again, what we're dividing the data into is groups. So we can accurately compare top 25% of this group with the top 25 of this group, independent on how many students there were. That's the beauty of the box plots. That's why they are a very favoured tool of statisticians. So it does not have to be the same to do a good comparison. All right, the dot plot below. So here's a VCAR question from Further Maths. This is a Year 12 question, girls. So step up to the plate here and see how you go with this one. So the dot plot below shows the distribution of the time in minutes that 50 people spent waiting to get help from a call centre. Okay, so what we've got is the dot plot there, and got lots of numbers down here and 3 numbers up there. All right, so I'll just point out a couple of things before you get too far into it. This is question 6 in Further Maths, and usually they're starting to get a little bit of game. Okay, usually these questions are starting to get a little bit trickier. So what I'm going to do is ask you to pause the video now and attempt to answer this question. And have a good think and a careful think about your answer, okay? And then what I want you to do is unpause it and check out the discussion point. And I hope you got it right, guys. I hope you got it right. Okay, so at this point, you've unpaused this video here. So what I'm going to note is that many students will go for either B or they'll go for E. And that's because what you'll do is you'll look at this data set and go, we've got 3 outliers. So Mr. Miller, there's 3 outliers, like nothing even to argue. So it's going to be either B or E. But in fact, girls, it's neither. Okay, so the plot thickens on this. All right, well, just because these are separated from the pack, it doesn't necessarily mean that they're outliers. So don't judge it by what it might look like. And VCAR have been very sneaky with this question. All right, so I'm going to show you which is the answer by doing a couple of quick calculations. There's 50 pieces of data in the data set. I'm going to divide them into 2 groups. That means there's 25 and 25. Now what I'm going to do is find the IQR and the Q3. Okay, so let's find the Q3 and the Q1 so we can generate the IQR. Okay, so the Q3 is going to be found by doing 25 plus 1, which is 26 on 2. That's the 13th piece of data. Let's go find it. 1, 2, 3, 4, 5, 6, 7. More, I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it looks to be around about, let's just say around about like maybe 51, maybe. Okay, let's go the other way and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 30. So our IQR is 21 or, roundabout, and our upper fence is 51. So we're going to go 51 plus 1.5 times the interquartile range, which is 21. All right, let's grab our calculator and do that. So 51 plus 1.5 times 21, and we get that, which is equal to 82.5. And hopefully you understand what's happened here. There is my fence. There is a figure that is or falls within the fence, okay? So in fact, we've got 1, 2 outliers, okay? So I'm looking for a box plot down here with 2 outliers, and there's only 1. So the answer is A. So I don't really care about the rest of it, all right? That's what I'm not fussed about there. I'm just looking for the fact that there's 2 outliers in it, and I can not even bother looking at the shape of the box plot. Some students in the past I've known to type in all of those or approximate each of those values. You could feasibly do that, but 1, that's boring. You're going to have to type in 50 pieces of data, and 2, you don't have that kind of time in a further maths exam. All right, so on to the questions, girls. 9D is the exercise. Check Firefly for the relevant questions.